So, this is the recording for the first week of my trigonometry class this semester. And we're just going to go through the material for the quiz. This quiz is on angle measure and trig functions. So, we're going to define our trig functions and we're going to talk about angle measure, and we'll talk about angular motion and arc length and stuff like that. So, um, let's first start with talking about angles. So, an angle is you have two rays that connect at their origin. A ray is half of a line. It starts at a point and goes in one direction forever. And the angle is the size of the angle is basically how different are the directions between these rays. We will define angles by how much of a circle they subtend. That is to say, if we put the corner of the angle at the center of a circle, what is the amount of the circle that is between the two rays and what amount of the circle is not? So, for instance, these rays are 90 degrees because we have a quarter of the circle subtended by the angle. Okay, subtended just means the part that's between the two rays of the angle. Okay, you might say, well, why does a circle get 360 degrees? Well, the Babylonians decided that 3,000 years ago, and we don't get to change that right now. There are reasons that they chose it, and it has to do with it makes division easier. But for us, we're just going to accept that a circle has 360 degrees. And that means that a quarter of the circle is going to have a quarter of 360 degrees, which is 90 degrees. And an eighth of the circle is going to have an eighth of the 360 degrees and be 45 degrees, and so on. So that's how we measure angle. Well, that is one way of measuring angle. We also can talk about just fractions of a rotation. So this angle might be 1/8 of a rotation, which is the same as being 45 degrees. Or here's the one that maybe we haven't seen before. This will be pi over 4 radians. And the way that we'll think of a radian is if we have a circle, this is the radius of a circle. That is the radius. We know that the circumference of the circle, that is all the way around a circle, is equal to 2 times pi times the radius. So that means that if we walked if the radius is 5, if we walk, here's our radius of 5, if we walk 5 units around the circle, we have walked 1 radius around the circle, and the angle that's produced would then be 1 radian of angle. Okay, so if our radius is 4 and we walk 8 units around the circle, we have gone 2 radians. And so all the way around is 2 pi radians. Halfway around is only going to be pi radians. That's going halfway around the circle. Quarter of the circle is going to be pi over 2 radians. So we have this ability to convert where 360 degrees equals 1 rotation, which equals 2 pi radians. That means that 180 degrees is equal to just pi times radians. Or we can word it as 180 degrees over pi radians equals 1, which is the same as pi radians over 180 degrees. We can use this to convert between radians and degrees, because multiplying by 1 doesn't change something's value. So if I have 57 degrees, if I multiply it by 1, that is to say, pi radians over 180 degrees, the degrees cancel, and I'm left with 57 pi over 180 radians. And I can throw that into a calculator if I want to get a decimal approximation of that. If I have 5 pi over 12 radians, and I want to convert this to degrees, I multiply by 180 degrees over pi radians. Radians cancel. This gives me 5 times pi times 180 degrees over 12 pi. 12 pi. The pi's cancel. 12 and 18 share a common factor, so I can cancel a 6 from here and a 6 from here. I can cancel a 2 from here and here. 5 times 15 is 75 degrees. So I can convert from some amount of radians to some number of degrees by using one of these conversion factors. Multiplying by 1 does not change the value of an expression. And since these two things are equal, that means that a fraction where the top and bottom are equal is 1. Okay, that went very fast, but you can stop and rewind if you want to see it again. Anyway, we will define our trig functions using a right triangle. If we mark one of the angles, let's call this angle theta. We have an opposite side to the angle, so this is opposite the angle. This is adjacent to the angle. Adjacent just means next to. It's a Latin word that means next to. And we have the hypotenuse. Hypotenuse always goes across from the 90-degree angle. And I don't know that I've said what the origin of the word hypotenuse is on a video before, but if you look at any really old geometry texts, they always put the right angle at the top, and the hypotenuse is on the bottom. Hypo is Greek for under, and tenus means like to cut across, or like to travel across, I guess. I don't speak Greek, but anyway, it's the thing that travels underneath the triangle. Under traveling, under crossing. And it's funny because even though modern math textbooks don't typically draw the triangle with the 90-degree corner in the top anymore, we still call it the hypotenuse, meaning the thing that goes underneath the angle, even though we usually draw it this way now. But anyway, if we have the triangle labeled this way, so we have an angle and we have an opposite and an adjacent and a hypotenuse, we can create 6 fractions and give them all names. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. We get 3 more. These are the cosecant, which is the hypotenuse over the opposite, the secant, which is the hypotenuse over the adjacent, and the cotangent, which is the adjacent over the hypotenuse. These are our 6 trig ratios. 6 trig functions if we plug in what this angle is, because for any two triangles, any two right triangles with the same angle, they will have the same trig values, even if the lengths of the triangles are different, because that angle will make all of the fractions equal. Just like how 1/2 equals 2/4. The way that the sides of a triangle, of a right triangle, relate to each other is if the angle is fixed. If we pick an angle and stick with the same angle, it doesn't matter if we have a small triangle with that angle or a big triangle with that angle. This side divided by this side is the same as this side divided by this side, which is neat. And it's very useful and valuable when you're working with triangles, and triangles pop up in all kinds of places. So, yeah. Anyway, now that we've defined our 6 trig functions, we should try and find some values for these trig functions. For instance, if I have a triangle where this side is 1 and this side is 1, and that angle is 90, it turns out that this angle becomes 45 and that angle also becomes 45. If we find out the lengths of the 3 sides, we can calculate, let's make this, say, 40 degrees. We have the sine of 45 degrees is going to be equal to the opposite divided by the hypotenuse. So if we find the hypotenuse, those 2 sides, we divide them, we get the sine. We have the cosine of 45 degrees is the adjacent divided by the hypotenuse. And the tangent of 45 degrees equals the opposite, which is 1, divided by the adjacent, which is also 1. So if we knew how to find the hypotenuse, we could find the value of sine and cosine. It turns out we have the Pythagorean theorem, which I might prove in a video in the future. The Pythagorean theorem says that a squared plus b squared equals c squared. Well, 1 squared is 1, 1 squared is also 1, and c squared is the thing we're solving for. 2 equals c squared, so c equals the square root of 2. So that means that the opposite divided by the hypotenuse is 1 over the square root of 2, and the adjacent divided by the hypotenuse is also 1 over the square root of 2. So these 3 values will come into play on question 1 of the quiz that you're doing. Okay. Now, if we look at these definitions up here, we notice that cosecant and sine are reciprocals of each other. Secant and cosine are reciprocals of each other, and tangent and cotangent are reciprocals. And what that means is that we just take this fraction and we flip it over. So that means that our sine, cosine, and tangent can also give us the cosecant. 1 over square root 2 is just square root 2. And 1 over 1 is 1. So that is one of the rows in the special angle table that is question 1 of the quiz that you're doing. Do you have to be able to derive all of these on your own from diagrams like I did here? No. No, I will not expect you to have these memorized, and I will not, well, let me rephrase. I will not expect you to be able to prove these, whether that means memorizing the proofs or becoming proficient enough in proofs to be able to do the proof yourself. But I think that you should all see a special angle table, a unit circle at some point in your trigonometry career. So that is how we find 45 degrees. To find 60 degrees, well, if we create a right triangle where the sides are 1, 1, and 1, Then we have 60 degrees here, here, and here. We take this, we split it down the center. Now this side is 1/2. This side is still 1, because all I'm doing is I'm cutting the triangle like this. And using the Pythagorean theorem, we can figure out what that side is. This is, let's call it side B. We know that a squared plus b squared equals c squared. So 1/4 plus b squared equals 1. So b squared equals 3/4. 1 minus 1/4 is 3/4. So b equals the square root of 3. The square root of 3/4, which turns out to be the square root of 3 over the square root of 4. Square root of 4 is 2. So b is √3/2. And this means that we can, this is a 60-degree angle. That means that we can write sine of 60 degrees equals the opposite over the hypotenuse. Anything divided by 1 is itself. The cosine of 60 degrees is the opposite divided by the hypotenuse. And the tangent of 60 degrees is the opposite divided by the adjacent. This might look a little scary at first, square root 3/2 over 1/2, but we can simplify fractions by multiplying the top and bottom of the fraction by the same number. 1/2 times 2 is 1. 1/2 times 2 is also 1. So square root 3/2 times 2 is square root 3. Anything divided by itself, or anything divided by 1 is itself. So that means that the tangent of 60 degrees equals the square root of 3. Okay. So there's our sine 60, cosine of 60, tangent of 60 gives us square root 3/2, 1/2, and square root 3. The reciprocals are 2 over square root 3. That's going to be the cosecant of 60 degrees. We have 2 is the cotangent, is the secant of 60 degrees. And 1 over square root 3 is the cotangent of 60 degrees. Then we notice, using that same triangle that we already solved for, which I mislabeled there. This here, we marked this side as 60 degrees. This side is, or this angle is 90 degrees. That means this angle is 30 degrees. Using the same triangle, this is the opposite of the 30-degree angle. So sine of 30 degrees equals the opposite divided by the hypotenuse, which is 1/2. Cosine of 30 degrees, the adjacent to the 30 is square root 3/2. The hypotenuse stays the same. So this becomes square root 3/2 over 1, which is just square root 3/2. And the tangent becomes 1/2 over the square root 3/2. We multiply by 2/2 to cancel the halves. Now we get 1 over square root 3. You take the reciprocal of these to find your secant, cosecant, and cotangent of 30 degrees. They can all be calculated out this way. So let's just make the chart. Put all of the values together. 0, pi over 6, pi over 4, pi over 3, pi over 2, sine cosine, tangent, cotangent, secant, and cosecant. So we get 0. This is 1 over 2. This is 1 over root 2. Square root 3 over 2. And this is 1. Cosine is the same values as sine, but in reverse order. That goes for all cofunctions, by the way. Sine and cosine are cofunctions. So we get the same values, but in reverse order. Tangent goes 0. And then we have, this is 1 over square root 3. 1 square root 3. And it's undefined here. Cotangent is cofunctions with tangent. So it's the same in reverse order. Okay. Some patterns to notice is, as we said earlier, sine and cosecant are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. Meaning that whatever value you have in cosine, you get the reciprocal of it in secant. And then we also have cofunctions, where whatever value you have in a function, in reverse order, you get the same value for the cofunction. Like so. So there are all of these relationships and patterns in here. And if you're interested in seeing more of those patterns, I have a video on trig special angles in my trigonometry playlist. But this should get you through the first question of the quiz. Hello? Okay. So now we want to talk about which functions are positive and which functions are negative in the 3 quadrants of the unit circle. So if I draw a circle of radius 1 centered at the origin, that means that the radius is 1. This point has coordinates x, y. And what that means is that if I make a triangle by dropping a line straight down to the x-axis, this length is x, and this length is y. So this is the opposite of this angle. This is the adjacent of this angle, and this is the hypotenuse. Which means that we can do all of our trig functions where sine of whatever that angle is, we'll use theta as our variable because we're already using x. X is already being used. We'll have to use something else. And theta is a traditional Greek letter that's used to represent angles. Okay, so sine of theta, theta is whatever angle this is here, is the opposite over the hypotenuse. But the hypotenuse is 1 and the opposite is y, so this equals y. The cosine is the adjacent over the hypotenuse, which is going to give us x. The tangent of the angle is the opposite over the adjacent, x over y. And then our cofunctions, where like cosecant is 1 over y, because it's 1 over sine. Secant is 1 over x, and cotangent of x is x over y. In quadrant 1, all of our variables are positive. That means that all of our trig functions will be positive because x and y are positive. In quadrant 2, traditionally we write these in Roman numerals. Quadrant 2, they're numbered going this way around. So quadrant 1, quadrant 2, x is negative, but y is positive. So that means even though all of the trig functions are positive here, in quadrant 2, sine is positive and cosecant is positive. But all of the other trig functions have an x in them, and x is negative. So that makes them negative. In quadrant 3, all of our variables are negative. So sine, cosine, cosecant, and secant all are negative. But the tangent and the cotangent have both variables, and the two negative signs cancel out. They cancel each other out. Tangent and cotangent are canceled. They have the x and the y negatives cancel out, leaving us with a positive. In quadrant 4, well, we've already had sine and cosecant get their day being positive. Tangent and cotangent got to be positive. In quadrant 4, x is positive, y is not. That leaves these two as the positives. We have cosine and secant as the two positive functions in the quadrant. So often the mnemonic for that is that if I draw my unit circle, this spells acts going clockwise. Cosine and its reciprocal, tangent and its reciprocal, sine and its reciprocal, all. These are what are positive in each quadrant. Okay, so that gets you through questions 1 and 2. Quadrant 3, question 3 is conversion between radians and degrees. Question 4 is conversion between radians and degrees as well. We already saw examples of that. Let's see. Question 5, we have two legs of a right triangle and we want to find out what the sine is. So if we have, my question says that A is 9 and B is 6. We want to figure out what is the sine of angle A, where A is 9 and B is 6. The convention is that the angle opposite is the capital letter of the variable you use for the side. So this is angle A because it is opposite side A. Side A is 9 units. This is 90-degree corner. So, for instance, this is capital C and is 90 degrees. And this is lowercase c because it's the side opposite that. To find sine, we're going to need the opposite over the hypotenuse. So opposite is A. This is the opposite. And the hypotenuse is C. We know A is 9. To find C, we're going to use the Pythagorean theorem. 9 squared plus 6 squared equals C squared. 81 plus 36 equals C squared. This gives us 117 equals C squared. So C equals the square root of 117. 117 is not a perfect square, but we will write that in anyway. Yeah, that is 117. Okay, so here's our answer. We plug it into a calculator. We round to 3 decimal places. The next question is a similar one. We're finding cosine instead of sine. If A and B are supplementary angles, what is angle B? Okay, so here we go. Supplementary means A and B are supplementary if A plus B equals 180. A and B are complementary if A plus B equals 90 degrees. So you're just going to plug in the value that you know into this equation and solve for the variable that you don't know. And complementary one is going to be the same. Now notice, complementary with an E. If you put an I there, it means saying something nice. If you put an E there, then it means the other part of something. So like, if I take a circle and split it, this is a part, and this is its complement. Meaning, because it says the E, it's the part that completes it. Not that it's nice to it. Not that we shouldn't be nice to things, but being complementary means, with an I, means saying something nice. And I'm typing this into Google to make sure I'm not looking like... Yeah. Google says the same thing as me. Merriam-Webster says the same thing. Okay, so I didn't just make that up. That is in the dictionary. Okay. So you can do complementary angles and supplementary angles. Let's talk about coterminous stuff. So if I have an angle, well, this angle, let's call it 45 degrees. This is the same angle as going negative 315 degrees. If I start facing the positive x-axis and I turn 45 degrees to my left, that's the same as turning 315 degrees to my right. These are coterminous. The terminus, is meaning the end, and co means same. So whether I turn, if I turn 100 degrees to my left, or if I turn negative 100 degrees, let's say 260 degrees, that is, if I turn left 260 degrees, I end up facing the same way. Termin, meaning end up, like how you end, and co, meaning same ending. End up the same way, end up looking the same way. Coterminous angles are angles that end up looking the same direction. So if I'm asked, like in this question here, it says we have an angle of negative 358 degrees, and I want to find one that's coterminous. So negative 358 means I rotate this way, 358 degrees in the negative direction. I want to figure out what is the coterminous angle that is going counterclockwise, the positive angle. That's going to be 2 degrees. 2 degrees to the left is the same as 358 degrees to the right. They end up pointing in the same direction. Okay. And the last question we should be needing for this is, we have a tree that is growing, and it is 9 feet tall, and it casts a 15-foot long shadow. And we have another tree that is 79 feet tall. Wow, that's big. No. It's casting a 79-foot shadow. And we want to know how big it is. If we're assuming that this is, roughly the same latitude and same time of day, then these triangles should make the same angles. The sun is coming from the same direction. This angle and this angle are the same. This angle and this angle are the same. They are similar triangles, which means that corresponding ratios should be equal. 9 over 15 should be equal to x over 79. And that means that 79 times 9 over 15 equals x. I plug that into a calculator and I get a number, and I round it to 3 decimal points, or I guess this says 2 decimal points, and I am good. This is not 79.9, this is 79 times 9. Okay. And those are all the types of questions on this week's quiz. I will try to get next week's video up earlier in the week. I hope you're having a good first week of class, and I look forward to helping you learn this material. I hope you enjoy it. I think trigonometry is a really pretty subject. But yeah, have a great week. See you next week.